Welcome to this test showing of my PicoSPINet. The device in question is that Pico there. Don't worry about all the other stuff that's on the PC, on the breadboard. It's all irrelevant, including that little chip there on the right. It's just purely the Pico. So we have two nodes. My original build of the machine and version 2 of the case with a very badly soldered keyboard. It's manky as hell. But anyway, there we go. So what we'll do is the Pico is powered directly on from the laptop, which is what you can see as the console being shown. If I power on each of the nodes, they have they're battery backed, so they will have their own power supply. And there we go, each one is gonna powered up. It's just booting off the ROM. So what we'll do is we'll get it to go through the startup scripts just so that we can get to a common point. Wait for these two to... I want it. Okay, so I'm going to excuse all the cameras. For some reason, Funny won't screencast via any recording software. It doesn't even appear as a window. So I have to use my mobile phone to record. And that just leaves me with this camera to do the screens. And the other camera I had just has dead battery. So, you know, we're going to go with this. So that's both of them booted. Right, so then what I do on each one is do a one cartridge device, which puts me through to the SPI port. And let's go do the same over here. And so, yeah, that's it. Okay. Now what I will do is slow the SPI port down. This is where my keyboard is badly soldered. Right, so that slows it down a little bit, and I'll do the same over here. Okay, so what we've got is various nodes. So if we do a get node, clear the screen and print it, node 1. If we then do get node 2, there, so that's node 2. Amazing, it's all working. That's a good sign. So what we'll do is we will do a net chat, and using 0 we'll do a broadcast to all nodes, so it's only going to be the 2. So we're there. Actually, oh no, okay, it is this. I think this one on the right, node 2, has actually got a slower clock in it. Right. Oh, actually, I think it's not clearing screen. That's why. So if we do hello node 2. Right, so this is a really simple chat client. So what it does is it just bashes out the single thing, single chars, which is what you can see on the terminal at the moment, and then it echoes back what is in the buffer for that node. So if I press enter on node 2, oh, here we go. Yeah, that's probably slowed the SPI port way too slow. But at least it shows some of the debug stuff terminal. So like that. Okay. So if I say okay, there we go. Just this keyboard on this one's awful. Node 2. Okay. So doing node 1. Oh, I can't remember the where's the question mark on my keyboard? Where did I put it? It's worn off the keycaps because I use just a Posca pen, and I haven't put it on the new keyboard. Okay, there is definitely a question mark somewhere. So what we'll do is we'll send that over to that node, and we'll send that over. Oh, okay, some of it's already gone to node 2. This is a really crappy, very basic chat client, you know. It's only like 1-2 lines of code. It's really awful. But it's showing you at least that these two are sending messages to one another in a very, very slow way. Oh, okay, that's as far as that as far as it's. Okay, it looks like it's probably feeding in as quickly as it's going. Okay, because I see that one's now started to. Okay, that one's not done anything. It's okay. So that one. Okay, so there's that. That one's still waiting for a response from the other one. So let's just press enter on that and see if it's got a message that I sent back. Yeah, there we go. So yeah, it's I should actually switch on the debug for the console. I'll do a quick show of the debug. Unfortunately for this chat client, I've not actually enabled any kind of smooth exit. So what I need to do is hit the reset button. And there we go. Let's just boot this one back up and I'll show some of the SPI part. Right. We'll enable some of the debug on. What I will also do is just do a reset on that one as well, and we'll run SPI a little bit quicker. It may drop characters because I haven't really stress tested it and there's no error detection. So 01 cart device. Right, so we put debug level 60 on. It's command byte 31 on the SPI. Enables SPI low on the chip select. Then SPI out, that command. SPI out the 60. And suddenly, as you see on the console, we've got loads more. Right, so I'm not gonna slow the SPI down. this is going to drop characters, I know it will. Right, let's get my node. Should still be 1, yes. And that one's still starting up. I'm sure I've put a slower clock in that, I must have. Might be an 8 in this, 8 megahertz in this one, and maybe a 10 megahertz in that one. Because it's what I had at hand, I was waiting for an order to come through, but I haven't soldered them on, so I could just drop a new one in. So let's device. Right, do a get node. Node 2, good. We are still working. Start that up. And we will start that one up. I am node 1. Okay, so that's sending that. You can see the console log going absolutely loopy. That's going to introduce some latency to the transmission. It's got nothing there to send back. So if we just press enter on the input, we should get that message, or maybe even a garbled message. Do, or not. Oh, okay. And press enter to start the program. Maybe. Oh. Enter. Oh, I think I see the console log throwing data out. Okay. So what's it got? It hasn't got anything back. Okay, let's see what that one's got. Okay, so I think the SPI and the full error logging, debug logging on the console is probably screwing up. Oh, there we go. Yeah, okay, so it's there's obviously a syncing multiplexing issue there. And okay, so that's gone through. That one came in. You know, this is 1 from okay, that's got some junk there. And what's that one? Is it still waiting for me to press something? No. Okay, it's doing something. Yeah. Okay. That's only got 2 characters through. Let's press enter on there and see if it's got anything in the buffer. No, nothing in the buffer. Oh, it looks like that's crashed. Yeah, the machine's locked up, crashed. Oh, I've got so many bugs still left in this. Let's see if there's anything it transmitted. Okay, no idea where that came from, but anyway, that one's gone to monitor mode because it's crashed. But anyway, at least with the first one, it gives you an idea of what stage we're at for the first go. Next up, I'm knowing it's roughly working, and it's just coding is likely to be the biggest issue. I am going to, well, as long as I know all the electrical stuff's fine, what I'm now going to do is do a proper full PCB design with that and with decent cabling, and then I can then develop the code on a slightly more stable, because obviously with these dodgy looking cables all over the place, that's going to introduce all sorts of noise and instability to the into the mix. So I need to be certain the cabling's fine. So what other features does this provide? So it's a Wi-Fi enabled Pico, so it's got Wi-Fi capability. I've got an NTP time server, so there is a SPI command to get the current time and bring it back to the node. And there's other various node things. It's all in the Python, MicroPython script. That's probably also another reason why it's a bit creaky. Could be it could be probably be better done in C, but you know, MicroPython's easier at the moment for prototyping. Let's see what else. Okay, also you can see there it's only got the ground connection. That white wire means the Pico can supply power to the machine, but obviously it's sort of kind of PoE. So the Pico will support 5 to 6 nodes. If you use 6, then you don't have PoE on any of the nodes, because what I do is I use those extra 8 pins on node 6 to provide power light to the other 5 node if you use a LED enabled RJ45 socket. So it will show you visually which sockets actually have power to them, which can be quite useful, because so you could enable one socket to actually have power and use that. Or now seeing these machines probably pull an amp, well, probably not an amp, I'm not sure how much they're pulling. I haven't actually put a meter on it to find out. They're all running off of a LiPo, built-in LiPo battery. So there it is there, and I've got a small little power boost thing that does the conversion. So I haven't really worked out what the load is. So I wouldn't probably put more than 2 nodes as a power supply, but it could effectively power the whole network or individual nodes. And with the PCB, there's like going to be dip switches to select which nodes are going to have power to them. It's there's that. Obviously, I've got setting up a internet gateway for them, so they can send and receive stuff on the internet. Yeah, it's a promising start, and the code's only just done, so who knows where we can go. That's for now then.